Imagine you are standing in a huge field. If you want to send a message to a friend on the other side, you have to yell, wave, or run over to them. No matter what you do, that message takes time to travel. This reflects what Albert Einstein believed was a fundamental rule of the universe. Nothing can travel faster than the speed of light. He called this principle locality. It's the reason that if the sun suddenly vanished, we wouldn't know for 8 minutes. This speed limit keeps the universe orderly, ensuring that causes always happen before effects. However, when scientists began studying the tiniest building blocks of our world, they found something that seemed to break Einstein's rule. They discovered what are called entangled particles. These are pairs of particles linked together like twins. If you measure one, the other reacts instantly, even if it is on the other side of the galaxy. Einstein found this idea deeply troubling. He famously called it spooky action at a distance. He argued that there must be a kind of secret plan or hidden variables that the particles agreed on before they were separated, much like two people carrying sealed envelopes with messages already written inside. For a long time, this remained a philosophical debate. Then a scientist named John Bell found a way to test it using mathematics. He showed that if you measured these particles at different angles, the secret plan theory and the spooky connection theory would produce different results. When the experiments were finally done, the outcome was clear. Einstein's secret plan was wrong. The particles really are connected across space in a way that appears faster than light. This revealed that our universe is non-local, meaning everything is connected in ways we cannot see. You might wonder whether this means we could send a text message to an alien planet instantly. Surprisingly, the answer is no. The behavior of these particles is completely random, like flipping a coin. Because we can't control the outcome, we can't send specific information. This randomness acts like a safeguard, preserving the logic of time and cause and effect. Some scientists take this even further with the many worlds theory, which suggests that the universe splits into different branches every time a particle is measured. In this view, every possible outcome exists in its own version of reality. When a top-tier Christian scientist looks at these discoveries, they don't see a conflict with faith. Instead of a cold, mechanical universe, they see a creation that is deeply unified and held together. The randomness of quantum physics may not be chaos at all, but the space God allows for freedom and divine action within natural laws. Whether viewed through a telescope or through prayer, the conclusion is the same. We live in a reality far more connected, mysterious, and grand than we ever imagined.